This is chapter 5.8, Completing the Square. We're going to look at example 1 in the book from page 268. The problem says to solve x squared plus 6x plus 9 equals 36. What I want to draw your attention to is you're seeing that this is a perfect square trinomial. So when you have a perfect square trinomial, completing the square is one of the ways in which you can solve this problem. So we've got a perfect square x squared, so we say to ourselves, what times what is going to give us x squared? Well, that's x. And then we say to ourselves, what times what will give us 9? Well, that's 3. And that equals 36. And so we're looking at, am I going to have plus plus, or am I going to have minus minus? Because in a perfect square trinomial, it's going to be the square of a binomial. Well, since this is plus and this is plus, it's got to be plus plus. Here's how you can check it. You've got inside 3x, outside 3x. 3x and 3x is 6x, so we know we're correct. This can be written x plus 3 squared equals 36. To get rid of the square, because your whole goal is to get down to the x, you're going to take the square root of both sides, because the square root of a square is that value. So if I take the square root of 2 squared, we know that the square root 2 squared is 4, square root of 4, that equals 2. So if you just went, the square root takes care of the square, you would see that your 2 is right here. You didn't have to go through that whole process. We're doing that same idea here. So we take the square root of x plus 3 squared, which will then leave us with x plus 3. Whatever I do to one side, I've got to do the other. So now I've got to take the square root of 36, which will leave us with 6. Now, 6 would be the normal answer, except, let me move it over just a little bit. 6 times 6 is 36, so 6 is one of the answers, but negative 6 times negative 6 is also 36. So we've got plus or minus 6, which just means, let's put it in red, that this answer is 6 or negative 6. That's all that plus or minus 6 means. So we've got x plus 3 equaling plus or minus 6. We subtract 3 using the subtraction property of equality from both sides. We're ending up with x equaling, now you're going to have two answers here. You're going to have positive 6 minus 3, so 6 minus 3, and you're going to have negative 6 minus 3. And negative 6 minus 3 is, if you use the additive inverse, it's like negative 6 plus a negative 3, and that's going to be negative 9. So you're going to end up with x equaling 6 minus 3 is 3, and negative 6 minus 3, which is the same as negative 6 plus a negative 3, is negative 9. It asked you to find the solutions. So we're going to go ahead and circle this. This is the solutions, and I'm going to do a little bit extra. So we're going to highlight what you needed to have. Those are your solutions. I don't need this over here, so I'm going to go ahead and erase it. So what I'm adding on in addition to what I've already done is we just found the solutions here. Solutions can also be known as roots or real roots. If you're graphing them, though, they're your x-intercepts, or the zeros of the solution, zeros of solution. So if I were to place a point at 3, so let's get this. This is going to be 3, 6, negative 3, negative 6, negative 9. Plot a point at 3. So my ordered pair is 3, 0 for that x-intercept. My other x-intercept is negative 9. Negative 9, 0. Now, this is a parabola because it's a quadratic. And so we know that the leading coefficient is positive 1. That means the parabola is going to open up. Now, I didn't calculate the vertex, so all I'm going to do is do this very rough sketch. This is not, it's got 2 points on it. That is not an acceptable sketch, but this does give us some picture in our mind of what to expect. So it's, again, more of a number sense situation. And remember, knowing the different terms for solutions, roots, real roots, x-intercept, zeros of a solution, is going to be very helpful as you encounter those terms throughout your Algebra 2 and beyond. All right, the next problem that you're going to try, you're going to do a little bit more on your own. I'll give you a little bit of coaching. And then we'll go ahead and have you shut off the recording, do it on your own, and then you'll turn it back on to check your understanding. All right, so we're continuing on. This is page 269, the checkpoints, about the middle of page 269, under the checkpoint part of the book. Number 2 says, find the value of c that makes x squared minus 12x plus c a perfect square trinomial. Oh, that was the wrong one, sorry. Back it up. We're actually doing number 1, my apologies. So number 1 is solving x squared minus 2x plus 1 equals 9. So this is, you're going to solve. That's your directions. First thing that you have to identify is that what's a perfect square trinomial. And if you take a look at the first term, x squared, that's a perfect square. If you take the last term, 1, that's a perfect square. So this is a method. Completing the square is a method when you have a perfect square trinomial for solving and finding the solutions, the x-intercepts. So when you have a perfect square trinomial, it's either going to be x plus something squared or x minus something squared. So we're going to go ahead and set that up. It's going to be equal to 9 still. And this was a perfect square trinomial right here. Perfect. I can't write it there. Perfect square trinomial. Okay. And then when you have a perfect square trinomial, then you end up with the square of a binomial. That's what we're about to do right now, is the square of a binomial. So you say square root of x squared. What is the square root of x squared, or what times what equals x squared? Well, that's x times x. And then you've got 1. What is the square root of 1, or what times 1 equals 1? Well, that's 1. And now you've got minus 2x in the middle, which means it's got to be minus minus. And you can double check it with FOIL. X times x is x squared, first term. Last term is negative 1 times negative 1, which is 1. Outside, inside. Outside is negative 1 times x, which is negative 1x. Inside is negative 1 times x, which is negative 1x. When you put those two together, you get negative 2x. This can all then be written x minus 1 squared equals 9. Now, I want you to take it from here, and I want you to solve for x. You're going to end up with 2 answers. So as soon as you've gotten it that far, then I want you to turn the recording back on, see how you did. Okay, so we have the page 269 checkpoint, and we got as far as the x minus 1 squared and equaling 9. To get rid of the square, because again our goal is to isolate the x, is to take the square root of x minus 1 squared, that's its inverse. If you do something to one side of an equation, you must do it to the other, so you take the square root of 9. You're left with x minus 1. And then square root of 9, most of you probably thought 3, but don't forget it's plus or minus 3, because 3 times 3 is 9, and negative 3 times 3 is 9. So it's 3 and negative 3. So then you add 1 to both of those to using the addition property of equality, which gives you x equaling 3 plus 1, which is 4, and x equaling negative 3 plus 1, which equals negative 2. Those are your solutions, which are your roots, or real roots. And in graphing, definitely called the x-intercepts. We're going to go ahead and plot those. I know that's extra, but we're going to go ahead and do it. And then they're also called the zeros of the equation. Okay, so they can be all of those things, the zeros of the equations as well. And so we're going to go ahead and plot that. We'll put a point at 4. The order pair, the x for that x-intercept is 4, 0, and negative 2. Plot a point on the x-axis. Negative 2, 0. This parabola, because it's a quadratic, it's going to be a parabola. It's going to open up And again, this is a super rough sketch. The leading coefficient was positive, that's why it opened up. So I want you to make sure that you note this is a rough sketch. 2 points without a vertex is by no means a good graph. This is just to help you understand mentally what you're getting. All right, we're going to try another problem. Okay, we're continuing on now with completing the square. Another situation would be to find c to make a perfect square trinomial. So for instance, if I had x squared minus 6x plus c, what would c have to be to make a perfect square trinomial? So the way in which you would go about this is, you know that c will equal b divided by 2 squared. So x squared minus 6x, that's what we have over here, plus b divided by 2 squared will give you your perfect square trinomial. Okay, so the first step would be to figure out what, we always get in the habit of doing what a is 1, b equals 2, b equals negative 6. So we now know what b is, so we would take negative 6 divided by 2 and we would square that. So that would be negative 3 squared, and that's going to equal c. So now we're ready to move on to that next step, which is x squared minus 6x plus, and we know that c is negative 3 squared, so it would be 9. Let's go ahead and actually finish that up. So c equals 9. That was one of the questions, what is c? And then you actually need to take the perfect square trinomial, which is what we have here. Square root of x squared is x. Square root of 9. You think of what's the square root of x squared, what's the square root of 9? That's 3. And then you need to decide if you're going to go plus plus or minus minus. Well, since this is minus 6x, you have to go minus minus. And if we did FOIL, x times x is x squared. Outside is negative 3x, inside negative 3x, put it together, that's negative 6x, and then negative 3 times negative 3 for the last term is 9. So then we write that as x minus 3 squared. And so the problem asked you for c, so we highlighted that. It also asked you to write the expression as the square of a binomial. This is the square of a binomial. X minus 3 is a binomial, and you're squaring it. From a perfect square trinomial, from a perfect square trinomial, you get the square of a binomial. Okay, I'm going to have you try one that's very similar to this. It's going to be number 1 in the checkpoint, and then you'll turn the recording back on once you've checked it. So let's go ahead and get it written down. Sorry, I think I said we were doing number 1. We're doing number 2. So it's page 269, the checkpoint, number 2, x squared minus 12x plus c. It says find the value of c, so we're going to find c, that makes x squared minus 12x plus c a perfect square trinomial. Then write the expression as the square of a binomial. So there's 2 things you need to do. It's a lot like the previous page's example. So if you need help, go back to that. When you're finished, go ahead and shut the recording on. And when you're finished, turn it back on and see how you did. Okay, so you knew your a was 1 and your b is negative 12. To find c, you take b divided by 2 and square it. So negative 12 divided by 2 is negative 6. Negative 6 squared is 36, so your c is 36. You now have the c value for your perfect square trinomial. So x squared minus 12x plus 36, that's your c value. You know that the square root, perfect square trinomials can be written as the square of a binomial. Here's how you figure out what to do. You know the square root of x squared is x, so you put an x here and an x here. You know the square root of 36 is 6, so you put a 6 here and 6 here. Since it's a subtraction on the middle term, it's got to be minus 6 minus 6. So it's x minus 6 squared. You can always check that with FOIL. X times x is x squared. Negative 6x is negative 12x, and negative 6 times negative 6 is positive 36. So we have now written this expression as the square of a binomial as was requested.